In lab, you will be taking many measurements. It is important to know the difference between a measurement that is precise and one that is accurate. Measurements with high precision are the result of repeated measurements that agree with each other closely or are reproducible. Accurate measurements are those that are close to the true value. Measurements can be precise and accurate. They can be accurate but not precise, or they can be even precise but not accurate. In order to have precision, there must be repeated measurements. If you take only one measurement, it could be accurate, but you could not say that it was precise. The actual mass used in a reaction is important to know as it pertains to the number of molecules that will be reacting. You will be using the following type of balance, which has sliding doors to prevent airflow from interfering with measurements. In order to tare the balance, the 0 button will reset the scale. Chemicals should never be put on the balance directly. A weighboat or other vessel such as a beaker should be used. You will encounter several different types of glassware. Beakers and Erlenmeyer flasks are often used to contain or hold liquid, as noted by the TC. These should not be used if you want accurate measurements of a liquid. For liquid measurements, graduated cylinders, graduated pipettes, or volumetric pipettes should be used. Liquids should be filled to the appropriate level using the meniscus, at eye level. Graduated cylinders and pipettes have several markings to indicate different volumes. Volumetric pipettes have one line marking and are designed to deliver only one volume. Tare the balance. Press on or tare. Determine and record the mass of a beaker, including all digits read on the balance. Make sure the doors are closed on the balance when measuring the mass of any object. Record the unknown identification number or letter for the object. Place the object in the beaker and record the combined mass in the report sheet. Place a weighboat on the balance and tare the balance. Measure the mass of the object again. There will be a display of graduated cylinders filled with different amounts of colored water. There are various sizes of cylinders. Read and record the volume of liquid contained in each graduated cylinder and record it in your report sheet. Use the pipette wheel to draw up deionized water. Remove the pipette wheel and place your thumb over the end of the pipette. Practice filling and emptying the pipette. Weigh a dry 50 ml beaker. Record all the digits on the balance. Pipette 10 milliliters of deionized water into the 50 ml beaker. Do this by drawing up liquid past the 10 ml mark. Quickly remove the pipette wheel and place your thumb over the end of the pipette. Slowly allow liquid to drain out to the 10 ml mark and put your thumb back on the end of the pipette. Remember, the bottom curve of the meniscus should meet at the 10 ml marking. Transfer the pipette tip to the beaker and allow the liquid to naturally drain out into the 50 ml beaker. Do not force the liquid out. Touch the tip of the pipette to the side of the beaker. Obtain a graduated pipette and measure 5 ml of vinegar and record the volume. Transfer the vinegar into a 250 ml beaker. Using a graduated cylinder, measure 25 ml of deionized water and record the volume. Add the water to the beaker containing vinegar. Add 2 drops of phenolphthalein and 2 drops of bromocresol green to the beaker with vinegar. Using a spatula or tweezers, weigh 2 pellets of sodium hydroxide. Add 1 pellet of sodium hydroxide to the beaker with vinegar and water. Stir until the sodium hydroxide dissolves completely. You may need to use the stirring rod to break up the sodium hydroxide. Observe your changes.